This video is going to show you how to draw covalently bonded molecules, okay? And you need to know straight off, the first thing with any bonding question is if they say show the bonding in a particular substance, you have to know what type of bonding it's going to be. Covalent bonding occurs between two non-metals, okay? So a reminder that the non-metals on the periodic table are on the right-hand side here. So any of these elements, if these are bonded together, and hydrogen is also a non-metal, so that's also included, that we're talking about bonding between those, okay? Now, when you have covalent bonding questions, I want you to, in your mind, realise that there are basically two types, okay? So there are questions with hydrogen, okay, and we'll deal with those first because they're nice and easy. And then there are basically ones without hydrogen, which most commonly are elements or compounds that don't contain hydrogen. So obviously elements wouldn't contain hydrogen, but compounds without hydrogen will also be included. So the reason I'm dividing it up in this way is hydrogen is obviously the simplest element on the periodic table, okay? Hydrogen, if you draw an electron configuration, okay, is just simply one electron. And remember, something will bond chemically to have a full outer shell. In order to have a full outer shell, hydrogen would need to gain one extra electron and share one extra electron to form a single covalent bond. So remember, a covalent bond is a shared pair of electrons. Okay, that's the definition of a covalent bond. And so we always draw it as a dot and a cross. So it can be drawn that way or it can be drawn vertically. If I was to draw, that would represent a single covalent bond. If I was to draw two, for example, that would represent a double bond. Okay, if I was to draw three, then that would represent a triple bond, like 3 lines. Okay, so you can have single, double and triple covalent bonds. But hydrogen, as we said, because it's only got one electron, it only ever needs one, it will only ever do this. So any compound that has hydrogen, the hydrogens become really easy. So let me just give you like 3 sort of really sort of simple examples. To kind of think about. Okay, so methane, I'm going to do ethene, and ammonia. Okay, you can see they all contain hydrogen. So the way we deal with hydrogen containing compounds is you start off with the non-hydrogen compound, which in this case is carbon, and we draw a circle around that. And the number of hydrogens you do, like I say, hydrogen never changes. You're always going to draw it as shown here. So you're going to draw a circle, put H in, and draw 1 dot and 1 cross, and that is it. So you do that however many times you've got hydrogen. So in this case for methane, I've got 4 hydrogens. So I just draw 4 circles, and it doesn't actually matter on the position around the molecule, but traditionally we do one top, like points of a compass, north, south, left, and east and west, like north and south, generally speaking. So that would be the formula for methane, because it's carbon with 4 hydrogens. And what you have to check for every element other than hydrogen is that it has 8 electrons in its outer shell. So you can see carbon here, if we check 1, 2, 3, 4, 5, 6, 7, 8 electrons, so that is complete. Okay, I'm going to do ammonia next and come back to this one in a moment. So ammonia again would have the non-hydrogen element in the middle, which is there, and then we draw 3 hydrogens. Okay, so I'm going to put 1 there, 1 there, and 1 there. You see, this is very easy. I don't ever change how I do it. It's just 1 dot, 1 cross, and a hydrogen. Now, when I count for how many electrons are in the shell for nitrogen now, we get 1, 2, 3, 4, 5, 6. It has to add up to 8, so all I do is finish it and make it add up to 8 and just put in the 2 additional electrons, like so. They're not bonded to hydrogen, they're just going to be a lone pair just floating there. So I have to make sure all elements apart from hydrogen add up to 8, okay? In this example here, we've got 2 carbons and 4 hydrogens. Now in this particular case, the 2 carbon atoms, okay, because they're the non-hydrogen atoms, will be bonded together, okay? And there are 4 hydrogens in total, and so I'm going to put 2 hydrogens onto each carbon in exactly the same way that we do, dot cross, dot cross. I'm putting these in the actual position they would be in the corners, but it doesn't matter where you actually put them on here, to be honest. But when I count up the number of electrons now that are left between each carbon, it's 1, 2, 3, 4. It has to add up to 8. So I've got to put two double bonds. Sorry, two bonds, so a double bond, two covalent bonds between these two carbons for it to work. So if I draw this out displayed, it would be a double bond carbon and then the 4 hydrogens like so. So you can see the carbons each have 4 covalent bonds. Carbon always forms 4 covalent bonds. So as a basic rule, that's useful to remember. But hydrogen is always just this dot cross. Okay, so the initial thing I want you to know is that for any hydrogen compound, hydrogen is always just a dot and a cross. However many hydrogens there are, start by drawing those on and then make sure it adds up to 8. Okay, so that's for hydrogen compounds. So for other compounds, you need to think a little bit differently. So for example, if I was doing oxygen, okay, or nitrogen, okay, so as an element, oxygen and nitrogen are obviously gases, okay? So oxygen is, if you look on the periodic table, it's got 8 electrons and it's got 2, therefore electron configuration is 2,6. So on the periodic table it would say 16 and 8. Nitrogen would say 14 and 7 on the periodic table, okay? So the electron configuration of nitrogen, for example, would be 2,5. Okay, so the reason you have to think with the electron configuration first now is it's again asking yourself that question, what do I need to do to get to 8? Okay, well, oxygen would need to gain 2 electrons and nitrogen would need to gain 3. Now, because we're doing that by sharing electrons, that means that oxygen has to form 2 covalent bonds. Okay, always. And nitrogen has to form 3 covalent bonds. Always. You'll remember a moment ago I said that carbon always forms 4 covalent bonds, and that's because it would be 2, 4. So it has to form 4 covalent bonds. There has to be 4 shared pairs of electrons in every case. So first thing is working out how many covalent bonds does it form. Okay, and just think, what do I need to do to get to 8? Okay, so in the case of oxygen, with elements, I've always got my 2 atoms, in this case my 2 oxygens, joined directly to each other, and so because it has to have 2 covalent bonds, remember the covalent bond is always a dot and a cross, and a dot and a cross. So I put my 2 covalent bonds between my 2 atoms, and then all I have to do is make sure that it then adds up to 8. 1 dot, 1 cross, all the way around, like so. I can draw it like this, okay, this is an acceptable way of drawing it, or as you know, I can draw the overlapping circles like so. Either would be acceptable. Okay, so some people prefer not to include the circles, and that's absolutely fine. So you always have your 2 covalent bonds. Okay, so just do another example here with nitrogen. So nitrogen is obviously bonded directly to each other. We know it has to form 3 covalent bonds, and the only thing is that they're bonding directly to each other, so those 3 covalent bonds have to be dot cross, dot cross, dot cross between them. Okay, obviously if I want to draw this as a circle, I would obviously just draw them overlapping like so. So those covalent bonds sit between the molecules, and then each one has to add up to 8, okay? And so each one's got 6 currently, so this would have 2, and this would have 2, okay? And that would be how you would draw it for nitrogen. So when you're doing it for elements, the elements are always directly bonded to each other. Ask yourself, how many bonds is it going to form? How many do I need to get to 8? Put that many covalent bonds between the 2 atoms, and then just make sure you've got the correct number of electrons around the outside again to always add up to 8. The only type of question that we haven't covered is if it's a compound that doesn't contain hydrogen, okay, so not an element. So an important example of that would say be carbon dioxide, okay, and that's because now we've got carbon and it's bonded directly to oxygen. So I've got my carbon here. It's going to be bonded directly to each of the 2 oxygens, okay? Now think about what we've done already. When I've got a compound like this, I have to do this process for both of the elements. So for carbon, as we've said, its electron configuration of the periodic table, okay, is going to be 2, 4. So to get to 8, carbon always has to form 4 covalent bonds. Oxygen, as we've already said, is 2, 6. to get to 8, it has to form 2 covalent bonds, and it can't form more than that. So in this example, okay, if I've got oxygen bonded directly to my carbon, then each oxygen has got to form 2 covalent bonds. It's got to be a dot and a cross and a dot and a cross. And because it's bonded directly to the carbon, both of those bonds have to be to the carbon. The same is true of this oxygen, dot and a cross and a dot and a cross. Now when I look at my carbon now, I actually already have my 8 electrons for carbon, so I don't need to draw anything else here. But if I look at each oxygen, 1, 2, 3, 4 electrons, I've got to finish this off and draw my 8 electrons like around the outside so that we can see it like so. So each element all has 8 electrons around the outside. So that's like the only additional exception. If you've got compounds that don't contain hydrogen, you do need to work out, just check how many covalent bonds each molecule has to do. And remember, you always draw covalent bonds the same way, a dot and a cross. So just to summarise this a different way, oxygen, as you can see in this first example, forms double bonds to itself. Nitrogen forms triple covalent bonds, so that's why it's so stable. That's why most of the air is made of that. And carbon dioxide forms 2 double bonds between the carbon and the oxygen. So as a molecule, that is what they look like.